Okay, sugars, here are your notes. And this is your first set of notes that you should be looking at. We're going to be talking about radicals and roots and simplifying radicals. A pro to this is that a graphing calculator, or excuse me, a regular calculator, just like this, can be super duper handy. Okay, so keep that around because you might need that. Okay, all right. A couple of things just to start up. Let's just remember what our squares are. Anything that is a perfect square, you can take the square root of. So all of these you can take the square root of. And I believe you guys know all these, so on and so forth. Dot, dot, dot. All right, the next one, perfect cubes. We've looked at these some. Just make sure that you know some of your perfect cubes. Now, there are different rules between perfect cubes and perfect squares. If it's a perfect square, it is just a number times itself, and then that gives you the perfect square, where a perfect cube is 3 numbers, okay, and being multiplied. Now that's really important because when you multiply a negative times a negative, you always get a positive. And when you multiply a positive times a positive, you always get a positive. But if you have 3 positives here, you could get a positive answer. Or if you have 3 negatives here, you could actually get a negative answer. So you actually can take the cube root of a negative number. And that is A-OK, which is very strange because you cannot take the square root of a negative number. We know that results in an I. All right, and perfect force we'll go ahead and go through. So 1 to the 4th is 1, 2 to the 4th is 16, 3 to the 4th is 81, 4 to the 4th, 256, 5 to the 4th, 625. Keep going, and dot, 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 dot. Okay? So a radical, this word right here, radical, my favorite word, that really just means a root. So you can have a square root, you can have a cube root, you can have a 4th root, and this little number right there, that little number is called the index. And this thing is called the radical sign. The number underneath it is called the radicand. Okay? If they have no number there, we just assume that n equals 2, which means take a square root. Okay? All right, remember when you take the square root, it can be a positive or a negative. So if I were to take the square root of 16, it could have been, what 2 numbers equals 16, or what 2 numbers multiply to give you 16, 4 times 4, or negative 4 times negative 4. So we're going to put a plus or minus 4. It could be 11 times 11, or negative 11 times negative 11, so let's put plus or minus 11. And 17 times 17 is 289, so that's plus or minus 17. Here, again, all of these are square roots, so we can take the square root of 4, which is 2, and the square root of 25, which is 5, and that is a plus or minus again. Now it gets a little bit more squirrely when you're talking about a cube root. So let's look at these cube roots right here. All right, so I have to think to myself, what number times itself gives me 8? So what number times itself gives you 8? And that would be 2 times 2 times 2. So the only answer could be a positive 2 here, because the only way that you could get 8 would be positive 2 times positive 2 times positive 2, and that would give you a positive 8. Same thing here, the only number that I could multiply would be a positive 7 times a positive 7 times a positive 7, and that would give me a positive 343. So the cube root of 343 is a positive 7. Now if you move on to 125, we know that that is 5 times 5 times 5, but the only way to get a negative would be if it were a negative 5 times a negative 5 times a negative 5. So the cube root of negative 125 is negative 5. And then, of course, we can come over here. This negative out front either belongs to the top or the bottom. So I usually just give that negative to the top, or you can keep it out front. The cube root of 1 is 1, and the cube root of 27 is 3. And of course, it'll have to have a negative out front. Now, the fourth root, this is where it gets even scarier. So what number multiplied times itself 4 times gives you 1? And we all know that that is a positive 1 or a negative 1, because a positive times a positive times a positive times a positive is a positive, or negative times a negative times a negative times a negative is also a positive. So it could have either been either one, a positive 1 or a negative 1. All right, so 7 times 7 times 7 times 7 is a positive 241, but also a negative 7 times a negative 7 times a negative also gives you a positive 241. So we are going to do a plus or minus 7. And this is 8. So it could either be 4 negatives, which becomes positive, or 4 positives. So our answer is plus or minus 8. And over here, 2 times 2 times 2 times 2, nope, gives you 16 down here in the denominator. And 3 times 3 times 3 times 3 gives you 81, so that will be a 3. Okay, moving on. So if our index is even, now remember that's just that little teeny tiny number right there is called an index. If our index is even and our radicand, which is the number underneath, is positive, then we will get 2 real solutions. Okay, so, and that would give us 2 roots. We have a plus or a minus. So an example of this would be the square root, that's called the index, of 81, and that would give us 2 real solutions, which would be plus or minus 9. Now, if I came down here and I had an even index, like the square root, but my radicand was a negative, that would actually leave me with 2 imaginary numbers, because I would have to take an I out front there. So it would be the square root of 81, but I would have a plus or minus I out front. So that would actually give us imaginary and 2 solutions. They'd just be a plus or minus, but it would have an I in it. And then our other 2, if they're odd and positive, yes, they'll be real. Odd and negative, absolutely real. You'll have 1 positive solution or 1 negative solution. That's basically what we just did up here. Just gives you an idea of what to expect when working these possible roots. Okay? All right, so down here, we're going to simplify radicals. And again, your calculator might do a good bit of this on some of the situations, so always check your calculator, okay? But it also can be done by hand, okay? You want to make sure that you take out the greatest common factor, multiply it out, that is a perfect square in this case, because we are doing a square root. So this is the square root of 9 times the square root of 13. With a little finagling, you can come up with that. We know what the square root of 9 is. It is 3. And we can't take the square root of 13. So that is it. Okay, that is my only answer there. We definitely have a positive solution there. All right, over here, same thing. We have 4 times, and that's still the square root of 320. So I'm going to carry the 4 down, and then I know that I can break this into 64 times 5. So the 4 stays, and the square root of 64 becomes 8. And then we still have the square root of 5. So 4 times 8 is 32, square roots of 5. Easy enough, those are square roots. Now, even scarier. So you have to look back up at your cube root list at the top of the page. I know an 8's in here, and an 8 is a perfect cube. So I'm going to carry the 2 down and do the cube root of 8. And it's 8 times 6 gives you 48. So that'll be times the cube root of 6. Well, I can't do anything with that, so I'll carry down the 2. The cube root of 8 is also 2. And then I have times the cube root of 6. So my final answer is 4 cube roots of 6. Now, while I'm at it, just check your calculator. It will do so much for you. So if you just do the square root of 117, it's going to do it for you. I'm not sure if it will do a cube root, so we can try to see. And to do a cube root, you can use this little button right there that has like the X root on it, right here above the caret symbol.